sales up here, and I've got unemployment as a variable. Let's run a simple regression, okay? Show you how to do that. You have to have the data series of equal lengths, right? You have to make sure they're both of equal length. We could take a holdout. We should take a holdout, but I'm going to show you the mechanics of running this first. And I'm going to use the entire data series. But when you run it for the assignment, for your project, make sure you take the holdout values, the 8 off the bottom, for both. Unemployment. Well, let's just do it. What the heck? Let's just insert a couple of columns. Okay? And I'm going to call this target holdout. Okay? And then I'm going to call this, for the x variable, that's for the y variable, it's holdout. For the x variable, we're going to call it forecast. Unemployment. Okay? So for the x variable, we're going to call that a forecast, and for the y variable, we're going to call it a holdout. Take 8 of these, 1, 2. How many do I have there? 1, 2, 3, 4, 5, 6, 7, 8. Control X. Put those babies up here for the target holdout. Control V. There you got 8 of them, yep. And then go down and grab the unemployment, and we're going to call this a forecast for unemployment. Control X. And we're going to put it over here in the unemployment forecast column. Control V. Okay, you see we're cheating on the real world, because in the real world you probably wouldn't have one of these, right? You wouldn't have a holdout. But in this case, we're going to use the unemployment actual values for the forecast for the x variables. See what we're doing? Then we go to Stat, Regression. Stay with regression. Don't let it lose you. Oh, God, is that me? Oh, my gosh. Sorry about that. My wife had to take the dog to the vet because he's licking his paw. And we have regression, fit regression model. You see that? Okay. And it'll already populate the response. The response happens to be target revenue, right? Make sure that you select target revenue. And it says continuous predictors. You know the difference between a continuous and a discrete number series? Continuous number series, the values can take on almost any number. Okay? They're continuous. The numerical values that can take on any value. You've got another group of variables, predictors that we'll get into, called the categorical predictors. And they're discrete. There are only certain values that they can take. There are limits to the values that those numbers can take on. There are no limits to the values up here for the continuous numbers. The data that you've collected for your x variables are all continuous variables. All right, so you put that x variable in the continuous slot, and let's look at storage. Make sure you check the residuals. Okay, say okay for that. And graphs, let's check the 4 and 1. Okay, make sure you check that one just for the heck of it. I think that's all we need for right now. Let's select OK. Bang! And here comes the 4 and 1 plot for the residuals. So it tells you what is missing. Can you see what's missing in this these fitted values? Seasonality is missing, and cycle. Oh, it's terrible, and it looks like some trend too. So it's missing a lot of stuff. Okay. Residuals look almost normally distributed, but they are skewed to one side, so skewed to the right, because it's got the highest numbers over here, the highest outliers. Okay? Let's look at the model itself. And it's broken down into some pieces. Here is the analysis of variance. ANOVA. Remember we talked about ANOVA before? Sum squared total. So these are the sum of squared values. The sum of squares of regression is right here. See that number? It's a pretty good size. Then you have the sum of squared error. Remember the SSE that we talked about? And if you added these two numbers together, you'd get this number. Sum of squares total. So those numbers that we were talking about appear in the ANOVA table. And if you divided the sum of squares regression, this number, this top number, by the sum of squares total, what would you get? You get R squared. You can try this at home if you want to, but you get this number. 41.3%. That's a coefficient of determination, the R squared, associated with a simple regression. If you add more variables, you have to move off of that and move the adjusted. Move to adjusted. But right now, keep it at the simple, for one variable, simple R squared. Remember, it's regression divided by total. Then we can look at the mean squared values, okay? And those are used to calculate the F statistic. You see, you've got an F value up here for the entire regression equation. Since you only have one variable, it's just repeated for the coefficient. But the F statistic that contributes to the, they contribute to the total F value. I want you to look and note the total F value. And the probability that F statistic is actually equal to 0 is what? It's very low. It's below 0.05. So it's acceptable at 95% confidence level. Okay. You can look it up in the table. For one variable, I don't have the T table, I mean the F table in front of me. It's probably going to yield you something like, maybe, anybody got a book? Maybe you got a book. I've got a plot, I mean a graph with it on there, but you look up the F statistic. I forgot to tell you one thing about the F statistic. Whenever you look it up, go back to your notes and make sure you note this. Whenever you look up that F statistic in the table, by looking at the number of variables across the top, this says we'll take the first column, right? Since we only have one variable, column 1K. And you look down the side, it's the number of observations minus K, that's minus 1 plus minus another one, minus 2 in this case. You look up the number, the F statistic, and then multiply it by 3. It's business convention, science convention, to make sure that this model applies to the population. So you always multiply the table F value by the big number 3. Okay? What does that mean? It's you're rest assured that you're at least 95% confident in the model itself. And I venture to say the F value is probably going to be around 7. That's kind of experience. Maybe 750, 7.5. This is 16.9. It exceeds 3 times the F table value. Okay? So what we can say is this relationship that we've got, and the R squared shows it, but the relationship that we have applies to the population. We can be 95% confident that that coefficient is developed in this model. Here's the model down here. Target revenue is equal to this times this number times unemployment. Okay? It's saying that these relationships that we've got captured in the model apply to the population of unemployment data and the entire population for target revenue, potential target revenue as well. And how do you read this? You're going to be asking here to interpret regression equations. This says for every 1 percentage point, whole percentage point increase in unemployment, it creates 339,846 million in target revenue. That's a lot of revenue created by 1 percentage point change in unemployment. So this is for unit change in unemployment, the X variable, times this gives you the solution for the equation. And you add it to the constant term, of course. But this is always, this coefficient for the X variable, unemployment, is always how much Y changes with a 1 unit change in X. Keep in mind, that's the relationship that's created by this model. Okay. Let's check to see whether or not this relationship is actually equal to 0. This coefficient is actually equal to 0. The t-value is 4.025. What is our threshold? 1.96 for a large sample size. So, we can say it's significant. It's not 0. What's the p-value? It's 0.001. What's the threshold for that? 0.05. Right? It's less than that, less than 0.05. It's significant at the 95% confidence level. So we can say that first, the coefficient exists, and second, it's a good representation of the real relationship between those two variables, unemployment and target revenue. I don't like to hear myself talk. I've got the worst voice in the world. It's grating to some people. My mother couldn't stand my voice, especially when they're hollering. So I hope you guys are not getting bored with it, because that's all I do in here is talk. I'll let you guys know. I'm turning it over to you right now. You tell us what we need to do. Huh? Why not? Would you dismiss the class?
Yeah.
Go up, stand up and say class dismissed.
Class, we can go home.
There you go. So I'll see you guys next time. Get out of here.